We now talk about refraction. So when a beam of light falls on a transparent medium, so you have a beam of light and falls on a transparent medium, part of it is reflected back and the rest of it enters the medium. So you have a beam of light here in red, part of it is reflected back and the rest enters the medium. Now if the direction of light is oblique to the surface, so oblique means it falls at some angle to the surface, its direction of propagation changes on entering the surface. So the light was going like this, and when it enters the surface, notice that its direction is changed. So when the light is incident on the surface, so say light falls on this point, say P, and say this is air and this is glass. So the light falls at point P. So I is the angle of incidence, so that is the angle which the incident ray makes with the normal. Notice that we are measuring angles with respect to the normal. Now part of the light gets reflected back and part of it enters the medium. So it enters the medium. So now the angle of this light entering the medium with respect to the normal to the surface is R. So notice that I is different from R if the medium is different. So this is air, it is entering glass. So the direction of propagation has changed. So the Snell's law links this I and R with the refractive index of the material. So this is the refractive index of say air, this is the refractive index of say glass. So Snell's law will link I, R and these two constants. N1 is a constant which is refractive index of air and N2 is a constant which is refractive index of glass. So let us now see the Snell's law. So the Snell's law states that the sine I by sine R, where I is the angle of incidence, R is the angle of refraction. So I is incidence, R is refraction, as we have just shown in the figure. This is equal to N2 over N1. N2 is this medium where the light enters, and N1 is the medium from which the light is initially coming. So the ratio of N2 to N1 is N to 1. So N to 1 is a constant, and this is called refractive index of the second medium with respect to the first medium. Now I want to make an important remark here. So the remark is, if suppose the light enters normal to the surface, so light enters like this, so then it will go straight through. There is no refraction. So there is no refraction. Therefore we say that the direction of light is oblique to the surface. If it is oblique, it changes its direction of propagation on entering the surface. So this light here, this is oblique. It enters and it changes the direction of propagation. But normal to the surface is not oblique. So normal to the surface remains normal and it does not change its direction of propagation. So this word oblique is important here. Now we talk about lateral shift. So say you have a glass slab like this. So you have a glass slab or any transparent material, and the light is entering like this. So the light enters from one side. So the light enters. So it enters the glass here. So once it enters, there is refraction, so it changes its direction of propagation. Once it comes out, again there is refraction. So there is refraction at 2 points. So there is refraction at this point, and then there is refraction again at this point. So the light emerges here. But if there was no glass, the light would have followed this dotted line. So if no glass, then this would have been the path of light. So path in absence of glass. In absence of glass. So these two rays, the final light, so this is the actual path because you have a glass, and this was path if there was no glass. So these two rays are parallel to each other. So these two are parallel. So the solid line and the dotted line are parallel to each other, and this is called the lateral shift. Now we talk about apparent depth. So suppose there is a fish or submarine in the water, and your eye is right here, and you're looking down at it. So the light coming from the submarine, this goes up and it gets refracted on the surface. So at this point it is getting refracted, and then it enters the eye. So the eye thinks that the ray is coming in a straight line. So the idea is that the eye always thinks that the ray is coming in a straight line. And so if you plot the line straight like this, then you see the submarine is here. So the idea is the light rays bend as they go from water to air, because you have changed the medium. So this is the actual path of light is in black, but to the eye it appears the object is here, because the eye will always take the straight line as the path. So eye takes the straight line as the path, whereas actually the light is just bending here.